Everyone, today I want to explain this polynomials and factorization of the second chapter for the 9th students for AP Maths textbook. So that is in the next topic, in next part of this polynomials and factorization, I will explain up to here. So next sum, in this do this 46 page number, that is do this second one. So we are doing the factorization for this page 46, do this. Okay, so second one, in that second one, 10m square minus 31m minus 132. Okay, so let us take this value as given that 10m square minus 31m minus 132 is equal to 0. Let us do this factorization for these two. So multiplication of this minus 132 into 10m square. So it is positive, it is negative. The product of these two negative, that is 132 1320 m square. Okay, the factors of this. Okay, in which table? The factors of this 1320 we have to take, and the sum of these two numbers which gives the minus 31 m. So for that I am taking this 51 into 24. Okay, 55 into 24, it gives 1320. Okay, so I want minus 31m, means the highest number I want to keep minus and plus. Okay, m square, so m into m. So the first number as it is you have to write like this, and the last number also just take this. Okay, so what is the common in between these two? 5m is the common. 10 is 5 is the factor for 10 and 55. So 5m I am taking it as common. So here it remained 2m minus 55 in 5 table 11 times 11 plus. Okay, so 12 I am taking it as common. So 12. So 2m minus 11, that is equal to 0. So here these two are common. 2m minus 11 is common in both, and here it is remained 5m plus 12 is equal to 0. So 0 has to equate for both the terms. So that is equal to 2m minus 11 is equal to 0. 5m plus 12 is equal to 0. 2m is equal to 11 and m is equal to 11. 5m is equal to 12, it comes in to other side, that is plus 12, it becomes minus 12. M is equal to minus 12 by 5. So here we have two values of this m. In that third sum, look at here, 12x square plus 11x plus 2. Okay, so given that 12x square plus 11x plus 2 is equal to 0. The product of these two, 24x square. In which table we have to take this 24, that is 8 3's. Okay, 8 3's 24, x into x. So but we want this plus, no, so when you add these two you will get 11x. Okay, 12x square plus 2 is equal to 0. What is common in these two? 4. I want to take this 4x. Okay, so 3x plus here 2 plus 1 I want to take here, 3x plus 2 is equal to 0. Here in both of this 3x plus 2 is common. So 3x plus 2, and what is remaining here? 4x plus 1. 4x plus 1, that is equal to 0. Both the terms has to equate with 0. That is 3x plus 2 is equal to 0. 4x plus 1 is equal to 0. 3x is equal to minus 2. X is equal to minus 2 by 3. This is first value. And 4x is equal to minus 1. X is equal to minus 1 by 4. So it is second value. Okay. Here we finished these two sums. In this, do this. Example 16. Look at here. Verify whether 2x to the power of 4 minus 6x cube plus 3x square plus 3x minus 2 is divisible by x square minus 3x plus 2 or not. How can you verify using factor theorem? Okay, first of all, is this was the factor of this polynomial or not, we have to check. Okay, so example 16. So first of all, given that the polynomial p of x is equal to 2x to the power of 4 minus 6x cube plus 3x square plus 3x minus 2. So g of x is x square minus 3x plus 2. Okay, so the zero of the polynomial g of x is that implies x square minus 3x plus 2 is equal to 0. So factorization for this 2x square. So what we have to take, two ones, x into x, but minus 3x is there, minus. Okay, first as it is you have to write, and the last one also you have to write as it is. In both of this x is common, so x minus 2 minus 1 is common, x minus 2. Okay, minus of minus plus it becomes, that is equal to 0. Here both the terms x minus 2 is common. The next what we have to remind, that is x minus 1. So you just equate both of this with 0. You will get x minus 2 is equal to 0, x minus 1 is equal to 0, x is equal to 2, x is equal to 1. Okay, so first of all you just substitute this 2 value in the given polynomial. So first one, substitute x minus 2, the x is equal to 2 in p of x. Okay, in p of x. So p of 2 is equal to 2 of 2 whole to the power of 4 minus 6 of 2 cube plus 3 of 2 square plus 3 of 2 minus 2. That implies 2 of 2 to the power of 4 means 2 2's 4, 4 2's 8, 8 2's 16 minus 6 of 2 cube means 8 plus 3 of 2 square means 4 plus 3 2's 6 minus 2. Okay, so that implies here 2 16's 32, 2 16's 32. Okay, minus 8 6, so 8 6 48, so minus 48 plus 3 4's 12 plus 6 minus 2. That implies, so look at here, these all are positive. 32 plus 12 44, 44 plus 6 40, 44, 32 plus 12 44, 44 plus 6 50. Okay, 50, minus 42 minus 2 minus 50, 50 minus 50 0. Okay, next check second one, on substituting x is equal to 1 in p of x. Okay, p of 1 is equal to 2 of 1 to the power of 4 minus 6 of 1 cube plus 3 of 1 square plus 3 of 1 minus 2. That implies 2 of 1 minus 6 of 1 plus 3 of 1 plus 3 ones 3 minus 2. That is equal to 2 ones 2 minus 6 ones 6 plus 3 of 1 3 plus 3 minus 2. Okay, so plus 2 minus 2 cancel. Okay, minus 6 plus 3 plus 3 plus 6 plus 6 minus 6 cancel, 0. So hence the given g of x is the factor of p of x. Okay, so for both the values of this factor, that is 0 of the polynomial, that is x is equal to 2, x is equal to 1, it gives the value of 0. Hence g of x is the factor of this p of x. So now look at here, So example 17. Factorize x cube minus 23x square plus 142x minus 120. Look at here, factorize. We have to factorize that one. Example 17. Okay. So given that the polynomial p of x is equal to x cube minus 23x square plus 142x minus 120. Okay, this is the given polynomial. We have to factorize it. But look at here, if by trial we don't know how to factorize the values. Okay, by trial we just take the value of for x, that is here I am taking it as by trial p of 1 is equal to 0. Verify it. Why? Because we just let us take x is equal to 1. X is equal to 1. Let us trial it. Okay, that implies p of 1 cube minus 23 of 1 square plus 142 of 1 minus 120. That implies 1 cube means 123 into 1 plus 142 minus 120. Okay, these two are negative numbers. These are positive numbers. 1 plus 142, 143. So addition of these two minus 143. You will get 0. Hence x minus 1 is the factor of p of x. Means x is equal to 1 means when it comes into other side x minus 1, it becomes x minus 1 is equal to 0. So x minus 1 is the factor of p of x. Why? Because it gives the value of 0. Okay, hence I am taking this x minus 1 as the factor of this equation. So just I am rearranging this equation as x cube minus 23x square plus 142x minus 120. After replacing, okay, just for convenience I am replacing the equation. Replacing the polynomial to find out the factors. Okay, so that implies I am taking it as, so x cube as it is I am taking, but minus 23x square I am taking it as minus 22x square minus x square. Minus 22x square minus x square. So it gives minus 23x square. Okay, plus I am taking this 142 as 22x plus 120x. So addition of these two you will get plus 142x minus 120. Okay, minus 120. I am taking it just for convenience. I rearranged it. Okay, x cube minus, first of all I am writing this one, x square minus 22x square plus 22x plus 120x minus 120. So look at here, take these terms as common. Okay, that implies here I am taking it as x I am taking as common, x square I am taking it as common. So x square, after taking this x square common, here I remained x minus 1 minus here I am taking 22x as common. Okay, so x is remained minus 1. So minus of minus plus, it becomes now 22x into 1 plus 22x. Here I am taking 120 as common, x minus 1. Okay, that is equal to 0. So in all these terms x minus 2 is common, x minus 1 is common. So what remained here? X square minus 22x plus 120 is equal to 0. You just equate this. Okay, that implies x minus 1 is equal to 0 is one of the factor, and the next one is x square minus 22x plus 120 is equal to 0. Here second. So by doing this factorization, so 120 x square, so what we have to take, so 12 into 10 x into x. So but we want this minus, no, minus 1 both sides. So x square plus 120 is equal to 0. So in between these two, x I am taking it as common. So x minus 12, here I am taking 10 as common, x minus 12, that is equal to 0. So in both the terms x minus 12 is there. Okay, remaining x minus 10, that is equal to 0. Again you just equate these two with x minus x, that is equal to 0. X minus 12 is equal to 0 and x minus 10 is equal to 0. Here we have one more value is here, x is equal to, it becomes 1. So one value is here, so x is equal to 12. Second value, x is equal to 10. Third value. So here 1 comma 12 comma 10 are the zeros of the given polynomials, and x minus 1, x minus 12, x minus 10 are the factors of the given cubic polynomial p of x. Okay, so here we finish with this sum. Somehow it is some difficult sum, so if you not understand, you just listen again and again. If you listened it through 2 times, you can understand in the better way. Okay, so next we will started this exercise 2.2. This exercise 2.4, the first sum was determine which of the following polynomials has x plus 1 as a factor. Okay, we have to check this, is this x plus 1 is a factor of this polynomials or not. Okay, so first sum in exercise 2.4, first Roman. Okay, first Roman, given that the first sum was given that the polynomial p of x is equal to x cube minus x square minus x plus 1, and g of x is equal to x plus 1. The 0 of the polynomial g of x is, so that implies x plus 1 is equal to 0. That implies x is equal to 1, it becomes minus 1. So minus 1, substitute x in p of x. Okay, that implies p of minus 1 is equal to minus 1 whole cube minus of minus 1 whole square minus of minus 1 plus 1. That implies here odd number is there in the power, so negative number has to remain. So 1 cube means 1 minus, here even number there is a power, that is even number, that is it becomes 1 square plus of minus plus 1 plus 1, that is equal to minus 1 plus 1 plus 1. So these all are cancelled, hence it becomes 0. Yes, x plus 1 is the factor of p of x. Okay, the first is yes, it is the factor. Second we have to check. Okay, so in the second sum, what was given that the polynomial p of x is equal to x to the power of 4 minus x cube plus x square minus x plus 1. So g of x is equal to x plus 1. 0 of the polynomial, 0 of g of x is, so that implies x plus 1 is equal to 0, x is equal to minus 1. Substitute x in p of x. That implies p of minus 1 is equal to minus 1 to the power of 4 minus of minus 1 by 1 to the power of 3 plus minus 1 whole square minus of minus 1 plus 1. That implies here even number is there, it becomes positive 1. 1 to the power of 4 means 1 minus, here odd number is there, so minus 1 plus here even number is there, so it becomes 1 minus of minus plus 1 plus 1. That implies 1 minus of minus plus 2 plus 1 plus 1 plus 1. So 1 plus 2 3, 3 plus 3 4, 6, that is equal to 6. So here 0 is not came here, so hence x plus 1 is not a factor of given p of x. Okay, for second it is not a factor of this p of x. For third, okay, given that the polynomial p of x is equal to x to the power of 4 plus 2x cube plus 2x square plus x plus 1. G of x is same, no? That is x plus 1. So 0 of g of x is, that implies x plus 1 is equal to 0. That implies x is equal to minus 1. So substitute x in p of x. So you will get p of minus 1 is equal to minus 1 whole to the power of 4 plus 2 of minus 1 whole cube plus 2 of minus 1 whole square plus minus 1 plus 1. Okay, so that implies here even number is there, hence it becomes 1. Here odd number is there, hence minus 1 is remained, plus 2 of minus 1. Here even number is there, so 2 of 1 plus 2 of 1 plus of minus 1 plus 1. That implies 1 plus of minus 2 into 1 2 plus 2 ones 2 minus 1 plus 1. So that implies these are cancelled, 1 is remained. So here hence x plus 1 is not a factor of p of x. In the third sum also x plus 1 is not a factor of p of x. Okay, in the fourth one given that the polynomial p of x is equal to x cube minus x square minus 3 minus root 3x plus root 3 is equal to 0. That is, and g of x as usual, that is equal to x plus 1. So 0 of the polynomial g of x is, that implies x plus 1 is equal to 0. That implies x is equal to minus 1. So substitute x in p of x. Okay, that implies p of minus 1 is equal to minus 1 whole cube minus of minus 1 whole square minus 3 minus root 3 into minus 1 plus root 3. That implies it is odd number, hence minus 1, minus even number, hence it becomes 1, minus, so in brackets minus 1 into 3 minus 3, minus of minus plus root 3. Okay, plus root 3. That implies minus 1 minus 1, minus of minus plus 3, minus of plus minus root 3 plus root 3. Plus root 3 minus root 3 cancel. Here minus 2 plus 3, that is equal to 1. Here hence x plus 1 is not a factor of the given polynomial p of x. Okay, for only for the first sum it is the factor of this p of x. For remaining 3 for the second sum you will get 6, and the third sum you got 1, and the fourth sum you got 1. So here for all these remaining sums it's not a factor of the given polynomials. So second sum, look at here, use the factor theorem to determine g of x is the factor of f of x in each of the following cases. Here 5 sums is there, we have to check is it is the factor of this one, is it is the factor of this one, is it is the factor of this one, we have to check. Okay, so in the second Roman the first sum is, so given that the polynomial f of x is equal to 5x cube plus x square minus 5x minus 1. So and g of x is equal to x plus 1. So 0 of g of x is, that implies x plus 1 is equal to 0, that implies x is equal to minus 1. Substitute this x in p of x, f of x, that implies 5 of minus 1 whole cube plus minus 1 whole square minus 5 of minus 1 minus 1, that implies 5 of cube is there minus 1 plus square is there, so it is even number, hence it becomes 1. Minus of minus plus 5 minus 1, that is equal to minus 5 plus 1 plus 5 minus 1. Minus 5 plus 5 cancel, plus 1 minus 1 cancel, that is equal to 0. Yes, g of x is the factor of f of x. Okay, second sum. So given that the polynomial p of x is equal to x cube plus 3x square plus 3x plus 1. Okay, x cube plus 3x square plus 3x plus 1, and g of x is equal to x plus 1. Okay, so look at here. So 0 of g of x is x plus 1 is equal to 0, that implies x is equal to minus 1. Substitute x in f of x. Okay, that implies f of minus 1 is equal to minus 1 whole cube plus 3 of minus 1 whole square plus 3 of minus 1 plus 1. That implies it is odd number, no, minus 1 is remained, plus 3 of, it is even number, so 1, plus of minus minus, 3 into 1 3 plus 1, that is equal to minus 1 plus 3 minus 3 plus 1, plus 3 minus 3 cancel, minus 1 plus 1 cancel, that is equal to 0. Yes, g of x is the factor of f of x. So third sum. Okay, given that the polynomial f of x is equal to x cube minus 4x square plus x plus 6. Okay, and g of x is equal to x minus 2. The 0 of the polynomial g of x is, that implies x minus 2 is equal to 0, that is equal to x is equal to plus 2. So substitute x in f of x, that implies f of 2 is equal to 2 cube minus 4 of 2 square plus 2 plus 6, that is equal to 2 cube means 8 minus 4 of 4 plus 2 plus 6, that is equal to 8 minus 16 plus 2 plus 6. Okay, that implies, so here these are positive, so 8 plus 2 10, 10 plus 6 16, 16 minus 16, that is equal to 0. Yes, g of x is the factor of f of x. Here for all the sums 1 2 3 sums you got, these are the factors of this f of x. Okay, fourth sum, let us check this fourth sum. So given that the polynomial f of x is equal to 3x cube plus x square minus 20x plus 12, and g of x is equal to 3x minus 2. 0 of the polynomial 0 of g of x is, okay, that implies 3x minus 2 is equal to 0, that is equal to 3x is equal to 2, x is equal to 2 by 3. So substitute x in f of x, that implies f of 2 by 3 is equal to 3 of 2 by 3 whole cube plus 2 by 3 whole square minus 20 of 2 by 3 plus 12, that implies 3 of 2 cube means 8 by 3 cube means 9. 3 cube means 27. Why? Because 3 has to multiply 3 times, no? So plus 2 square means 4 by 3 square means 9. Minus, so 20 into 2, 40 by 3 plus 12 by 1. That implies, so 3 has to cancel 9 times. Okay, 8 by 9 plus 4 by 9 minus 40 by 3 plus 12 by 1. That implies LCM of this all 9. 9 is there in the denominator, hence I am writing this numerator, plus here also 9 is there, so 4 minus, in the 3 table 9 is 3 times, 3 40s, 3 40s 120, plus in one table 9 times, 9 120s, okay, 1 not 2. That is equal to, these are positive, okay, these are positive. So addition of these two, 12 plus 110, 108, 120 minus 120 by 9, that is equal to 0 by 9, that is equal to 0. If in the numerator, if the 0 is there, then it becomes 0. Yes, g of x is the factor of f of x. Okay, now let's check the fifth sum. Given that the polynomial f of x is equal to 4x cube plus 20x square plus 33x plus 18. So and g of x is equal to 2x plus 3. The 0 of the polynomial g of x is, okay, so that implies 2x plus 3 is equal to 0. That implies 2x is equal to minus 3, x is equal to minus 3 by 2. Okay, substitute x in f of x. That implies f of minus 3 by 2, that is equal to 4 of minus 3 by 2 whole cube plus 20 of minus 3 by 2 whole square plus 33 of minus 3 by 2 plus 18. Here 18 is there. Okay, that implies 4 of, here odd number, minus is remained. So 3 cube means 27 by 2 cube means 8 plus 20. Here it is even number is there in the power, hence it becomes 3 square means 9 by 2 square means 4 plus of minus 33 into 3, 99 by 2 plus 18. Okay, that implies here 2 times, 4 5 times. So minus 27 by 2 plus here 9 5s 45. Okay, minus 99 by 2 plus 18 that is equal to, okay, so you just write here, so minus 27 by 2 minus 99 by 2, 40 plus 48, 45 plus 18. So addition of these two, okay, minus 27 by 2 minus 99 by 2 plus addition of these two, 8 plus 5, 3, 1, so 63. Okay, is 1 is there. So LCM of these all, so in the denominator 2's are there, so I am writing as it is, that is 99 plus 1 table 2 times 2 63s, so 6 126. Okay, that implies, look at here, the addition of these two, minus 126 plus 126 by 2. So plus 1 minus 126 plus 126 cancel, 0 by, that implies 0 by 2, that is equal to 0. Yes, g of x is the factor of f of x. So here in the second Roman, all the 5 sums, all the 5 sums are factors of the given polynomials f of x. Okay, here we finished the second Roman also. Next, third. It is the third sum. We have to show that x minus 2, x plus 3, x minus 4 are the factors of this given polynomial. 3 we have to check, okay, is these three are factors or not. We have to check and verify it and show that, we have to show that, okay. So third sum. So given that the polynomial p of x is equal to x cube minus 3 of 3x square minus 10x plus 24, okay. So first one, okay, g of x is x minus 2, okay. 0 of the g of x is x minus 2 is equal to 0, that implies x is equal to 2. So 2 has to check first, okay. That implies substitute x in p of x. That implies p of 2 is equal to 2 cube minus 3 of 2 square minus 10 of 2 plus 24. That implies 2 cube means 8 minus 3 of 4 minus 10 to 20 plus 24. That implies 8 minus 12 minus 20 plus 24. These two are positive numbers, okay. So 24 plus 8, 32. So these two are negative numbers, minus 32, that is equal to 0. Yes, x minus 2 is the factor of f of x, p of x, okay. So second one, g of x is x plus 3, okay, x plus 3. 0 of g of x is x plus 3 is equal to 0. That implies x is equal to minus 3. X is equal to minus 3. Substitute x in p of x. That implies, so p of minus 3 is equal to minus 3 whole cube minus 3 of minus 3 whole square minus 10 of minus 3 plus 24. That implies here odd number is there, minus 27 minus 3 of 9. Here even number is there, hence it is minus of minus plus 3 tens 27 minus 3 nines 27 plus 30. So here it is minus of minus 30 plus 24, okay. So addition of these two, minus 54. So these two are negative numbers, hence it is minus 54. These two are positive, hence minus plus 54. So minus 54 plus 54 cancelled, hence 0 we got. So yes, x plus 3 is also a factor of f of p of x, okay. So third, in this third, g of x is x minus 4. The 0 of the polynomial g of x is x minus 4 is equal to 0. That implies x is equal to 4. So substitute x in p of x. That implies p of 4 is equal to, so 4 cube minus 3 of 4 square minus 10 of 4 plus 24. That implies 4 cube means 4 has to multiply 3 times. 4 fours 16, 16 fours 64 minus 3 of 4 square means 16 minus 10 fours 40 plus 24. That implies 64 minus, so but when you multiply 3 into 16 you will get 8, 48 minus 40 plus, here these two are positive numbers, okay. So the positive number 64 plus 24, 88. So these two are cancelled, hence you get 0. Yes, x minus 4 is also a factor of p of x. Hence here in this given sum, all are the factors of the given sum. Okay, just like that you have to do this, you just do this fourth sum also. Okay, show that x plus 4, x minus 3, x minus 7 are the factors of this given polynomial. You just do this by your own. Okay, just like the above sum. Okay, in the next video I will upload from this fifth sum. Okay, thank you.